So today we are going to finish off with hypothesis testing. So if you remember last time I gave you guys a worksheet. We did an exercise. We did most of the questions. There were 2 left. So we're going to do those 2 and then I added 2 more that we will do together. So after that, I think you will be quite confident in solving questions like this. The procedure is pretty much the same. We have those steps that you need to follow. Step 1, you need to state your hypotheses. Remember that the claim in the question, or what the question is asking you to test, that goes hand in hand with your alternative hypothesis. You calculate the test statistic, you formulate a decision rule, you make a decision, and then you write a conclusion. That's basically it. Okay, so let's do this question over here. You are given the following information obtained from a random sample of 5 observations. So far we've only dealt with a t-test and a z-test. So when you see a sample size that is less than 30, your mind should already start thinking, oh, I'm probably going to have to do a t-test. Okay, especially if the population standard deviation is not given, as is the case here. Okay, so we have a random sample of 5 observations taken from a large population, and here are the values that we got: 32, 34, 32, 30, and 32. Then we have to use 5% significance level to test the claim that the mean is more than 30 by answering the following questions. So A, state the hypothesis that you would use to test the claim. So A, we have our null hypothesis, H naught, and then we have our alternative. Now we say that the alternative goes hand in hand with the claim that is made in the question, and in the question it says that the mean is more than 30. So this more than 30, that tells us this is a 2-tailed test. So sorry, not a 2-tailed, it's a 1-tailed. And I am going to put greater than in the null hypothesis, because that is what more than 30 means. So I will say mu is greater than 30. This is the claim, and it goes hand in hand with the alternative hypothesis. And then the null hypothesis is just the opposite of whatever you have written here. So for the null hypothesis, you would then say mu is less than or equal to 30. That is step number 1. Then step number 2 is to calculate the test statistic. So here we said we are not using Z. The reason we're not using Z is because our sample is small. So we have a small sample, n is equal to 5, and sigma is unknown. So this should tell us that we're using T. Okay, so now that we know that, we need to calculate the T. So the T that we calculate, this, we still use the same formula, x bar minus mu over, this time instead of sigma, we will say S over the square root of n. So right now the only thing we know is n and mu. We need to calculate x bar and S. So here there's only 5 values. It's not very difficult to work out the mean or the standard deviation. So we do that, say that x bar, this is equal to the sum of all the x's divided by how many I have. This is equal to 160 over 5. and this is equal to 32. Okay, so that is our X bar. Then we work out S. This is equal to a big square root, the sum of the squares. So I square each of the values, then add them together, and then I subtract. Let me just write the square root better. And then I subtract the sum of all the x's squared divided by n, and this is all divided by n minus 1. Okay, and then you substitute the values in your big square root. So over here we said you square each of the sample elements. So 32 you square it, 34 you square it, 32, 30, 32 you square them, then add them all together. Then what you should get, or what I got, this is 5,128. Then minus, this is just the 160 squared, so it's the sum of all the x's, then you square that, so that's just 120 squared. I'll just write it as 120 squared. I divide by n, there's 5 elements, so I put 5, and then this is all divided by n minus 1, so 5 minus 1, which is equal to 4. And this, you type it in on your calculator. I'll give you a minute to do that. Type it in. Try and do everything in one step, so you're not working out, let's say, the numerator first, then you divide, and then you take the square root. It's very easy to make a mistake like that when you do it that way. Okay, does somebody want to tell us what they got?
Um, 1.14.
1 point?
1.4142.
Okay, that is also what I got. So 1.4 142 13562. Okay, and then we can round this off to 4 decimal places. So this is 1.4142. Okay, but remember, we're not done. We were working out the test statistic. We just had to find out X bar, or work out X bar, which we did over here, and work out the standard deviation. Now we will use this formula. So I'm just going to copy it. Okay, and this is equal to, now I substitute each of my values. X bar, I got 32. Mu, that is the one from the question, or what we've written over here, it's 30. Then we divide by S. Here you can use the 1 to 4 decimal places or this one. It won't really make too much of a difference. So this is 1.4142, and then I divide by the square root of 5. So on your calculator, the way you type it should be like that with brackets. So again, let's take a minute, type this in on your calculator, and then let me know what you get. Anybody with the answer? Excuse me.
3.16227766.
Okay, so that I got 3.162307987. Okay, and then when we round this off to 4 decimal places, I think our values will be the same. So T that you calculated is approximately 3.1623. Okay, so this is our T statistic that we have calculated. Then, go back to the question. It says, okay, we've done B. I didn't label it, but this is where B starts over here. Then we look at C. It says find the critical value of values and state the rejection rule. So remember the critical values, we are testing at 5% level of significance. This is C. So what we're looking at is your T graph like that. And we say this is an upper tail test because our alternative hypothesis says greater than. So we're looking at this part over here. So this area here is 0.05. Now we need to work out what this value is over here. So this is just going to be the value of T 0.05, and then the degrees of freedom is 1 less than the number that you have in your sample. We have 5 in our sample, so I say 5 minus 1, that is equal to 4. So this you read from your T table. Okay, it's very small, but I hope you can see it. If not, I'm sure you have a T table from the last test. This is the same one. I should be able to follow along. Okay, so we said that T is 0.05, so we're in this column, and then our degrees of freedom are 4. So we go, this is 1, 2, 3, 4, this value over here. That is the critical T value. Okay, so this is 2.131847. And we go back to the question. So this is equal to 2.131847. Okay, critical value. Then our decision rule, we say that we reject H naught if the T that we calculated is greater than, that would mean it is in this region. So if it's greater than our T value over here, if it is greater than 2 point, I cannot write now. Let me just copy and paste. And the 2 does not copy. Okay, so if it is greater than 2.131897. Okay, that is the second step. This is our rejection region. You can label that. This is the rejection region. And this is our...
Sorry, madam. Did you say 89 or 847? Which one of the two?
8. Oh, it's 47. Sorry, it's the way I've written it here. This is, I should write it better for anybody reading this later. Okay, let me just write it. This is 2.13. This is 2.131847. So this is the value we're reading from the table. Okay, and over here, you just write whatever can fit. My pen does not want to work. This is 2. 2.1318. Okay, that's all that can fit there, but you get the idea. So if we get a T value that we calculated, which is greater than this value over here, that means it'll fall in the rejected region. If it's here, this is what we call the acceptable region. So any number that we get that is less than this value over here is acceptable. If we get a value greater than, it is now in the rejection region, then we will have to reject the null hypothesis. Okay, so let's go back to the question. We had to find the critical values. We did. That was the 2.1318. Then we had to state the rejection rule, which we did. We said that we will reject H naught if the T that we get is greater than our critical value. Then the next step, D, is give your decision for this test. D, we will say that since the T that we calculated, we got 3.1623. This is greater than the critical value, which is equal to the 2.13. We reject H naught. Okay, so you can see the value that we calculated is greater than the critical value, making it fall in the rejection region. So our decision is to reject H naught. Then the last part of the question is give your conclusion on the claim. So the conclusion is where you explain what it means to reject or fail to reject H naught, depending on what you have done. Here, you can state this a little bit differently, but the idea must be the same. So we conclude at 5% level of significance that the true population mean is greater than 30. Is that what H naught says? No, we rejected H naught, so is greater than 30. Okay, so here there isn't anything about shoppers and if one is better than another, because the question itself just gave us some numbers and we were asked to test whether the mean is more than 30 or is it less than 30. Okay, so here just saying this part here that the true mean is more than 30. That is enough based on the information that we're given. If we're given more information like the price is greater than 140, 175, don't just stop and say the true mean is greater than 175. Say the true mean of the prices, or use the information that is given to you in the question. Okay. And then we are done. So this question was broken down into 5 parts, one for each of the steps that you do when you are testing your hypothesis. Most of the time, the question will be given just like we have this next one over here. You just have to do the test, remember the 5 steps and follow them. Now let's look at this one, number 5, a mobile phone.
Sorry, may you just go back just for 1 second? Sorry, may you please go back to the previous? Yes, thank you. Just 1 second. Let me just take a picture of the. Okay, you can remove. Thank you.
Oh. All right. So here, a mobile phone service provider, Cell D Mobile, claims that it has 15% of the prepaid mobile phone market. A competitor who commissioned a market research company to conduct a survey amongst prepaid mobile phone users challenged this claim. The market research company randomly selected 360 prepaid mobile users and found that 42 users subscribed to Cell D Mobile as a service provider. A test at the 1% level of significance. Cell D Mobile's claim that they have a 15% share of the prepaid mobile phone market. Now this question here just tells us to test. It doesn't say check if it's greater than or if it's less than. So that should tell you that this is a two-tailed test. So words like check that, test whether it is less than, test that this one is better than the other one, stuff like that should tell you, okay, I'm dealing with a one-tailed. But when it's left open like this, that should tell you it is a two-tailed test. So A, we have a two-tailed test. And now we follow our steps. So the first step was to state our hypotheses. So we have H naught and the alternative hypothesis. Now remember, with a two-tailed test, the equal to will go in the null hypothesis and the not equal to goes with the alternative hypothesis. So this company is claiming that they have a 15% share in the mobile phone company. So we will say that pi, not mu this time, because this is proportion. It's 15% of the population instead of 15 people in the population. So that's why we're using pi instead of mu. So we say pi is equal to 0.15, that is 15%. And the alternative is just the opposite. Pi is not equal to 0.15. Okay, so with a two-tailed test, the equal to goes with the null hypothesis, then the alternative just has the not equal to. So this is step number 1. Step number 2, we said you need to calculate the test statistic. So when we're dealing with a proportion, our test statistic, we use Z. So we say Z that we calculate. This is equal to P minus pi. This is divided by big square root pi 1 minus pi divided by, yes?
Why are we saying that the alternative hypothesis is not equal to 15%?
Because it's a two-tailed test. With a two-tailed test, the alternative is the one that always has not equal to.
Always.
Always.
Okay, and this applies to whether it's just a population or a sample.
What do you mean if it's a population or a sample?
I mean, if we're using pi or if you're using mu.
Do you mean why am I using pi here instead of mu?
No, I got that. I'm just trying to understand the concept now. Like when you say it's a two-tailed test, then that
Yes.
means that the alternative hypothesis is the opposite of the claim. That's just what
Yes.
I'm. Okay.
Yes.
All right.
Okay. And as a rule, equal to goes with the null hypothesis. If you've noticed, our null hypothesis, when we had less than or equal to, the equal to was part of the null hypothesis. So let me just see if we have over here. You can see with my null, the equal to, I put it with the null hypothesis, not here. I never put an equal to at the alternative. And if you go back to all the questions we've done, the equal to always goes with the null hypothesis.
I see. It's also on the notes. Okay. Thank you, ma'am.
Now we substitute P over here. We read the question. We are told that it's 42 users out of 360. So P is just 42 over 360. So we say 42 over 360. And then we subtract pi. Pi is what you stated in your hypotheses. So this is 0.15. And then we divide this by the square root. 0.15, 1 minus 0.15. This is all over n. N is the 360 from your sample. Okay, so again, 1 minute, please calculate that and let me know what you get. Okay, do we have an answer? Okay, I got Z that we calculated. I got negative 1.77. 122.9771, and then we can round this off to 4 decimal places. So this is approximately equal to negative 1.7712. Okay, that was step number 2. Step number 3 is our decision rule. Now remember that this is a two-tailed test, so we will draw our Z like that, and we will have a rejection region in the lower tail and a rejection region in the upper tail. Now, the sum of these two rejection regions must add up to 0.01 because we are testing at 1%. So it's not 5% this time, it's 1%. So this area here plus this area over there should add up to 1%. So this is 0.005, and then this area is also 0.005. So what we do is we look for this Z alpha over here that gives us an area of, I should say alpha over 2 because I divided over 2. Okay, that gives me an area of 0.05. So to do that, I go to my normal table. Okay, I'm not sure if it's clear for you guys, but if not, you should have a copy there with you. Now, what you do is you look inside the table for the value that is closest to 0.05. Okay, where is that? Okay, so these two values here. You see these two values over here. These are the two values that are closest to 0.05, and they're equally close to 0.05, so I can add them together. So I'll take the z-score, negative 2.57 and negative 2.58, add them together, divide by 2. Okay, so let us do that. So this is negative 2.575, and because my normal table is, so my normal graph is symmetric, the value here that gives me an area of negative of 0.05 is the same as the value over here, except on this side it is positive. So here my Z alpha over 2, this is going to be equal to 2.575. So my critical values, this is plus or minus 2.575. So remember this 2.575, I got it by working out the average of 2.5 2.57 and 2.58 because both of those values were equally close to the value that gives me the area of 0.05. Okay, so now I need to state the decision rule. So the rule is that I will reject H naught if there are two cases here. If the Z that I calculated is less than negative 2.575 or the Z that I calculate is greater than 2.575. So that means it would fall in this region here, being less than negative 2.575, or it would fall in this region here, meaning it is greater than 2.575. So here with the two-tailed test, I have two rejection regions. Just highlight them. So this area here and that area there. This is my rejection region. That is also rejection region. And the area that is not shaded, that is my acceptable area. Okay, so that was step number 3. Step number 4, you need to make a decision. So we go back and look at the Z that we calculated, and then we ask ourselves, does it meet the criteria to be rejected? So that means, is it less than negative 2.575? And we say, no, it is not less than that. And the second part, is it greater than 2.575? No, it is not. So it would fall somewhere over here. This is where it's negative, sorry. It'll fall somewhere here. Okay, but that is still in the acceptable region. Okay, then we write down our decision. Since the Z that we calculated is equal to, or it's approximately equal to negative 1.7712. We fail to reject H naught. So that is our decision. We have failed to reject H naught. And then the last step is to make a conclusion. Now your conclusion should go hand in hand with whatever it is you are asked to work out or test over here. So it's not just we fail to reject and you stop there. Okay, so this you can say it in this way. It can be concluded that cell D mobile phone market let's see 8 is equal to 15% width 99% confidence.
Hi, ma'am. I have a question.
Yes.
Is there always specific instances where you would state it is 99% confident, or with at 99% confidence level, or can you also say with 1% level of significance?
Yes, you can use either of those. So you can say 1% level of significance or 99% level of confidence. Okay, but you cannot switch the two. So you cannot say 1% level of confidence. That would not even sound correct. If somebody tells you they're 1% confident about something, you don't trust what they're saying. So you can use, I think we did in some of the previous questions, I'm not sure. Okay, like this one here. We said we conclude with 5% level of significance. So you can word it however you want to. So either use 5% level of significance or say 95% confident. Okay. Okay, so that is the conclusion you would make. So again, you can word it a little bit differently. It is really up to you. But I do want to see the conclusion matching what you have worked out and what it means, not in a statistical way. So if somebody reads, oh, okay, so cell D does have a market of 15% or something like that, so that layman people can understand what it is you are saying, and then how confident you are. You're 99% confident, or say 1% level of significance. Okay, then let's do the second part of the question. We test at the 10% level of significance whether cell D, mobile's share of the prepaid mobile phone market, is significantly less than 15%. Okay, so again, words like less than 15%, that should tell you that it is a one-tailed test, and the claim, which is it's less than 15%, is going to go with the alternative hypothesis. So B here, this is a one-tailed test. Okay, so we follow the same procedure. Our H naught and our alternative. So we have H naught and our alternative. The alternative says it's less than, because that is the claim. So pi is less than 0.15. This is the claim. And the opposite of that, you say pi is greater than or equal to 0.15. So again, the equal to always goes with the null hypothesis. You never put an equal to over there. Then we would have to work out our Z, or calculate the Z, but nothing has changed. It's just the second part of the question. So the Z calculated value is still equal to negative 1.7712. Okay, because we're still using the same data, just testing at a different level of significance. and testing something different, but the data that we're using is exactly the same, so there's no need to recalculate it. Then the decision rule is going to change because our alpha has changed, and the level of significance that we're using has changed, and what it is we're testing has changed. So our decision rule is different. So here, this is what we're looking for. So in the alternative, we have less than, so that should tell you we're in the lower tail. So our rejection region is going to be this region over here. And this time alpha is, it's 10%, which is 0.1. So this is 0.1. That area over there should be equal to 0.1. And it's a one-tailed test, so I'm not dividing it by 2. So I just write the 0.1 over there. So I need to work out this Z alpha over here. Okay. Yeah, my Z of alpha. So what I do is I will go to my normal table and then look for the value that gives me 0.1. Okay, 0.1. Okay, these are all 0.1, 0.1. Okay, so it's somewhere between these two here.
Oh.
Okay, so it's between those two, and I can see that this one is closer to it, so I can just take this one. You can also take the average. It doesn't really matter because we're not really interested in the value itself. We're not using it in any calculations. We just use it to compare with the Z that we calculated. So decimal at the end, or the last decimal point, will not make a difference. So here I'll just take this one because it is closer than that one. So this is negative 1.28. Negative 1.28. So this is our critical value. Okay, so if this is our critical value, we need to then state a rule that relates to the critical value. So we've shaded this part over here as our rejection region, and this is our acceptable region. So this means that if we get a Z, if we calculate a Z value that is less than this value here, then we will reject the null hypothesis. Sorry. So our rule is that we will reject H naught if the Z that we calculate is less than negative 1.28. Okay, then the next step is to make a decision. So we look at the and then we compare it with the critical value. This is in the rejection region, okay, because this is less than that, so we will have to reject the null hypothesis. So since the Z that we calculated, this was negative 1.7712, this is less than negative 1.28, we reject H naught. And then you write a conclusion based on what it is you got. Say we conclude. With 9, let's say conclude. You conclude with 90% confidence that cell D mobile, its market share is less than 15%. Okay, so that is what we would then say. Is that fine? Are we okay so far?
Sorry,
Okay,
ma'am.
yes.
Your conclusion, shouldn't you say that it is not less than 15% share?
What did we do here? We rejected H naught. That means we accept the alternative. So if we reject this one here, then we must go with the alternative. The alternative says it is less than.
Oh, okay.
Yeah. Okay. Then let's do number 6. We are told that a lecturer from the IT department at NUST is of the opinion that more than, so you can see here more words like this tell me that I'm going to be doing a one-tailed test, and it's the upper, most probably. Okay, is of the opinion that more than 75% of the lecturers at NUST want to have access to NUST internet while on vacation. A staff member in the Human Resource Department is not convinced and took a sample of 60 lecturers to verify the lecturer's claim. She found that 48 are in favor of getting access to NUST internet while on vacation. Test the validity of the lecturer's claim at 5% level of significance. So here, like I said, this is a one-tailed. Okay, the reason is this word here, more. Okay, then from here we just follow the same procedure. We state our hypotheses. So we have H naught and the alternative. So remember, the alternative must say the same thing as the claim. So this lecture here claims that the proportion is more than 75. So that is what our alternative will be, that pi is greater than 0.75. And then here there's no equal to, just greater than. Okay, even if the question says is of the opinion that it is more or equal to this, your alternative must be strict, either greater than or less than. You never include the equal to with the alternative. That always goes with the null hypothesis. Then the opposite of that is just pi is less than 0.75. Okay, that is the first step. Second step is we need to calculate our Z. So here, the z that we calculate, this is the formula. We say p minus pi over a big square root pi 1 minus pi divided by n. Okay, now p, that is the 48 out of the 60 that we got from the sample, and then pi is the 0.75 and n is our 60 over there. So we just substitute. This is 48 over 60 minus 0.75. This is all divided by a big square root. My pi, this is 0.75. Then I say 1 minus 0.75. And then this is divided by n. N is the 60 over here. So again, take a few minutes, just a minute, exactly a minute, to work that out. So it's always good to practice using your calculator. So while I'm fixing these, please work it out on your calculator. Okay, do we have an answer?
Okay, I'm not sure if I did it the right way, but then I got 0.8944279191.
Okay, that is also what I got. So this is 0.89442719, and you can approximate this to 4 decimal places, 0.8944. Okay, so that is step number 2. Then step number 3 is we need a decision rule. So we say that this is a one-tailed test, and because of the more over here, it is an upper-tailed test. So this is what we're looking at. So it's an upper-tailed test. This is our rejection region over here. And this is our acceptable region. So we need to work out what this critical value is over here. Now, because we are testing at 5% level of significance, that means that this rejection region should have an area of 0.05. So this area here should be 0.05. So again, we go to our normal table and find 0.05 in the normal table. Now remember, you only divide by 2 if you are doing a two-tail test. This is a one-tail test, so I don't divide the 0.05 by 2. So I look for 0.05. Okay. Okay, so it would be somewhere here. And you can see that these two values are equally close to 0.05. So these two values over here, and then we read the two of them and then divide by 2. So this is negative 1.64 and this is negative 1.645. Now, because this is an upper tailed test, it's on the up here. We're reading this value over here, and our table is symmetric, then this will just be positive 1.645.
But Pande, why did she close this door?
Okay, let's see. So we're here. All right, so this critical value over here, this is equal to 1.645. So remember, I said it is not negative because it is on the upper tail of our Z or normal table, but it is symmetric, that the area that gives us 0.05 in the lower tail is the same, sorry, the value that gives us the 0.05 is the same except for the sign. Okay, so now that we have that, we need to state the rule. With the rule, we will reject H naught if the Z that we calculated is greater than 1.645. Okay, now that we've stated our rule, we need to make a decision. Now the Z that we calculated was 0.8944. So we compare that to 1.645. It is not less than, it is not greater than our critical value. That means we will fail to reject H naught. So we say that since the Z that we calculated is equal to 0.8944, and this is less than 1.645, and we said we'll only reject if we get one that is greater than 1.645. That means we fail to reject H naught. Okay, so again, here we don't usually say we accept H naught. It's either we reject it or you fail to reject it, and that's how we word it. So I would also like to see that when you are writing, instead of saying we accept it, say we fail to reject it. And then the last part is to make a conclusion. The conclusion should answer the question that the HR member was trying to answer. Okay, so doing that, you can say something like, we conclude with 95% confidence that the true proportion of lecturers that want access to NUST internet during vacation is less than 75%. Okay, so here what I want to see is your 95% confidence or 5% level of significance, and what that means, or 75%, less than 75% of NUST lecturers want access to the internet. Or you could also say the true proportion of lecturers who want internet access is not more than 75% at 5% level of significance. So that is also saying the same thing. Okay. Then the last one. The National Institute of Mental Health published an article stating that in any one-year period, approximately 9.5% of American adults suffer from depression. Suppose that in a survey of 300 people in a certain town, 7 of them suffered from depression. Conduct a hypothesis test at 1% of significance to determine if the true proportion of people in that town suffering from depression is lower than the percent in the general adult American population. So again, here the word lower, that tells us that we are dealing with a one-tailed test. So this is a one-tailed test. Okay, then we follow the procedures. You start with your hypotheses, you calculate your Z, then you formulate your decision rule, you make a decision, and then come to a conclusion. So our H0 and our alternative. So remember, the alternative goes with the claim or whatever it is you are asked to test. Now here we were asked to test if the proportion is lower, that means less than. So in the alternative, I want to see the less than symbol. So we'll say pi is less than 0.095. So this is the claim or whatever it is we were asked to check. Okay, and then our null hypothesis is just the opposite of whatever the alternative is saying. So we have pi is greater than or equal to, and the equal to always goes with the null hypothesis, is greater than or equal to 0.095. That is step number 1. Step number 2, we need to calculate a Z. So the Z that we calculate, we use the formula P minus pi over big square root pi multiplied by 1 minus pi. This is over n, which should also be under the square root. And then this is equal to P. That is the number that you got from your sample. So we had a sample of 300 people, and how many people in that sample said they suffered from depression? It's 7. So our P is going to be 7 over 300. We have 7 over 300. And then pi is whatever we have in our hypotheses. So this is 0.095. And then this is all divided by this big square root. Pi 0.095. 1 minus 0.095. This should all be under the square root. Divide by n, which is 300. So again, please try this on your calculator and let me know what you get. Okay, do we have any answers?
I don't know if this is accurate, but I found negative 4.233.
Okay, that's all what I got. Okay, so negative
Okay.
4.233, 423, 734, and then we can round this off to 4 decimals. So the Z that we calculate is approximately equal to negative 4.233. Okay, then the next step is our rejection rule. So remember, we're dealing with a one-tailed test, and this is a lower tailed test because in my alternative hypothesis, I have less than, so that's a lower tail test. Okay, so this is my rejection region. This area over here should be equal to 0.01 because I am testing at 1% level of significance. So the area in the rejection region should be equal to 0.01, and I don't divide by 2 because I'm dealing with a one-tailed test. Now this Z alpha over here, I have to read it from my table. So I look for 0.01 in my table, or the closest value to that. Erase that one. Okay, 0.01. Okay, all right, so it is right there in the middle. So between those two. Okay, you can say this is closer. You can take that one, it's fine, or you can work out the average. They're not too far. This is 2 points away, and this is 1 point or 0.0. Yeah, they're pretty close, both pretty close. So here I will take the average, and doing that, my Z alpha is negative 2.3, 325. 325, yes. Okay. Then we go back. Okay, so this is negative 2.325. Okay, then we state what our rule is. So the rule is we will reject H naught. When will we reject H naught? If the Z that we calculate is less than negative 2.325. And then from here, we make a decision. So we say that since the Z that we calculated, it's over here, is negative 4.233, this is less than the Z alpha, which is equal to negative 2.325. It falls in the rejection region. It falls in the rejection region. Therefore, we will reject H naught. And then make a conclusion. What does that mean in layman's terms? Say we conclude with 99% confidence. That, what was the question saying? The true proportion of people in that town, that the true proportion of people suffering from depression in the town is less than that of the general American public, less than the general adult American population. Okay, and that is it. So you can see there are 5 steps. All you have to do is follow them. You will either have a one-tailed or a two-tailed. With one-tailed, you should look for words like less than, greater than, this is better than this. Do most people prefer this? Stuff like that when it comes to proportion. And then one-tailed, it could go either way. It's not, those words are not used. Then your alternative hypothesis is the one that always has the claim. It is always a strict inequality, so it's either strictly less than or strictly greater than, or if it's a two-tailed, then the not equal to goes to the alternative. This Z statistic, or the T statistic, I'm sure you know how to calculate it, so there's not a problem there. Then your rejection region, make sure your rule is correct, then make a decision, and then a conclusion. So your conclusion should be not very statistical, just plain, I believe we conclude, this is how confident we are, and this is what we are concluding. Okay, so I see it's already 8 o'clock. I'm glad we managed to finish these questions. I will stop here for now, but if you have any questions, please feel free to ask. Otherwise, I will see you guys on Monday.